Before we find the value of these 5 examples, let's review some of the words associated with exponents. First word is base, and on this page we have quite a few of them. 2 is a base, -2 is a base, 2 is a base, -2 is a base, and here only 2 is a base. It's very important to realize that the negative means -1 times 2 to the -4. 3 more bases, A, and A. Next word is exponent, and we have some positive exponents and negative exponents. 4 positive exponents, 2 4s, an N and an M, and 4 negative exponents, 3 -4s and a -M. Next few words, repeated multiplication is showing right here, but I think it would be useful to have a look at what that means using numbers. Here's a tool that's very useful to show repeated multiplication. If you go to mathisfun.com and search exponents, you'll probably find it. Here we have a base of 2 and an exponent of 3. We say that this is 2 cubed, or 2 to the power 3. The expanded version of 2 cubed is 2 times 2 times 2, and this is what repeated multiplication looks like. The value of 2 cubed is 8. 8, written as a power of 2, is 2 cubed. When we increase the value of the exponent, the number of terms being multiplied changes. In other words, the n value changes, the number of terms being multiplied. The value of 64, written as a power of 2, is 2 to the 6. When we increase the base, the number that's being multiplied changes. If we change the base to a negative number, we need to make sure that we surround the base with brackets. If we have an odd number for the exponent and a negative base, the value will be negative. And if we have an even number for the exponent with a negative base, the value will be positive. Now let's get back to our examples we started with. We have 5 to do without a calculator. First example, 2 to the 4 would be 2 times 2 times 2 times 2, which is 4 times 4, which is 16. Second example is very similar, only this time the base is the -2. And that answer is 4 times 4, which is 16 as well. If we have a base that's negative and an even exponent, the answer or the value will be positive. But if we have a negative base and an odd exponent, the answer would be negative. Odd exponent, negative base. That's really important to remember. So we'll draw a thinking bubble. We know that 2 to the 4 is 16. We showed that. Well, what would be 2 to the -4? We can't think of repeated multiplication here. We can't go right to here because we have a negative exponent. But we can use the negative exponent law to help us out here. When we see a -4 exponent in the numerator, we can move the base down to the denominator and change the exponent to a positive. And that will give us 1 over 2 times 2 times 2 times 2, which is 1 over 16. When we have a negative exponent like these two here, and the bases are in the numerator, we can move the bases down to the denominator. But remember this one here, the -1. Be careful. We'll move the -2 down and change the exponent to a positive. and the numerator gets a 1. And now we can expand. It's a negative 2 times a negative 2 times the negative 2 times the negative 2 with the 1 on the top in the numerator, which equals 1 over 16. And the last one, remember to keep the negative there because it's like a negative 1 times 2 to the negative 4. And we just show it as a negative out here. We'll move the base down. The base is just a 2. And change the exponent to a positive, and the numerator becomes a 1, which is negative 1 over 2 times 2 times 2 times 2, which is negative 1 over 16. Let's see if we can do these questions faster. 2 to the 4 is 16. Negative 2 to the 4 is 16 as well. 2 to the negative 4 is 1 over 2 to the 4, which is 1 over 16. Negative 2 to the negative 4 is 1 over negative 2 to the 4, which is 1 over 16. And the last one, double D, keep the negative, send the base down, change it to a positive, which results in negative 1 over 16. Good job. When we're looking to solve a problem in math, it's useful to use our previous knowledge and try to look for patterns. And that's what we'll do when we're thinking about 2 to the negative 4. If we start out with 2 to the 5, we know that answer is 32. 2 to the 4 is 16, and 2 cubed is 8. 2 squared is 4. When we have a pattern starting to develop here, we can rely on that. Each time we decrease the exponent by 1, we're actually dividing the value by 2. 32 divided by 2 gave us the 16 right there. And then 16 divided by 2 gave us the 8 right there. And 8 divided by 2 gave us the 4 right there. And therefore, 2 to the 1 would be 4 divided by 2, which is 2. And 2 to the 0 would be 2 divided by 2, which is 1. And you might remember that anything to the 0 is 1. Now, how about 2 to the negative 1, and 2 to the negative 2, and 2 to the negative 3, and the one we're working towards, 2 to the negative 4? Well, this one is going to be 1 divided by 2, which is 1/2. And this one is going to be 1/2 divided by 2, which is 1/2 times 1/2, which is 1/4, or 1/4. And this one is going to be 1/8 because of 1/4 divided by 2, which is 1/4 times 1/2, which is 1/8. And then the last one will be 1/16 because of 1/8 divided by 2. Notice that the negative exponents become positive exponents if you move the base to the denominator. We can see clearly where the negative exponent law comes from. Back to math is fun. Look at the value of 32, and each time we decrease the exponent, that value is divided by 2. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. 1 divided by 2 is 1/2, or 0.5, or 5/10. 1/2 divided by 2 is 1/4, 0.25, or 25 hundredths. 1/4 divided by 2 is 1/8, or 0.125, or 125 thousandths. 1/8 divided by 2 is 1/16, or 0.0625, or, let's see if I can remember, 625 10,000ths. I think you get the point. Do you have doubts using the negative exponent law? Hopefully not. Hopefully what you've seen here in this video is you can think about what you know and apply it to the new learning. Good work.